Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
This is a very, very exciting time for the Human Landing System program. They've spent a lot of blood, sweat, and tears over this last couple years getting ready for this moment.
We're really excited to bring you the announcement of who NASA is going to continue to finish out the Human Landing System and take humans back to the moon. NASA has chosen SpaceX to return us to the moon. I am so excited to partner with SpaceX in this fantastic endeavor for the Artemis suite of missions. So congratulations to the SpaceX team.
The SpaceX design is a single-stage solution using their Starship. It provides extensive volume for the crew with 2 airlocks and ample down mass capability. The SpaceX proposal included in-space propellant transfer demonstration and uncrewed test landing.
So now that we've selected our partner, and for the next phase going forward, we have to make sure that the testing occurs, because we're not going to launch humans until we have a successful test. So we will be working to make sure that the design and everything that we have going forward so far is ready to go.
We're going to the moon to explore, and we're going to the moon for scientific discovery.
Our destiny is always to go and see what's further and what's next.
The moon is a stepping stone, and the moon is a place we need to learn how to live so that we can continue to go beyond.
We are focused. We are focused on all that lies before us. Only together will we bring to life this global ambition of returning to the moon. And while our work is far from finished, we've never been closer to seeing a new generation step beyond our home planet. We are building on the achievements of those who came before. The giants who conquered gravity and raised a banner in the heavens. They beckon us to go farther, to the moon and on to Mars, to seek a deeper understanding of our universe and bring all that we learn home. 2020 was a year of unpredictable hardships, and yet, step by step, we resolve to press forward toward this grand vision. The daily efforts of thousands of suppliers from all across this country and around the world fed into stunning milestones and laid the groundwork for history.
Launch team, go.
Artemis has been woven into our culture. It has fostered collaboration across the aisles and across the ponds. It has grown beyond plans and preparations to include hardware and software. And now, it has a heartbeat. You can feel the momentum. It is undeniable. We are going. And together, we will see Artemis light the way.
Our mission to the moon is no longer some far-fetched dream. This is reality. We are going.
This is the next step in evolution.
They're not just PowerPoint slides. They're actually metals being bent, shaped, formed to build the things that we're going to use.
This is real. This is going to happen. We're going.
We are going to the moon to learn how to live on other planets for the benefit of all.
Let's go.
3, 2, 1, 0. Ignition. Liftoff.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust, provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program, and there are companies all across our country that have a part in it, so there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon. Then, Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the service module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway, land on the surface of the moon.
We are there for, weeks, months on end. And there, we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there within the next couple of decades.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
It's very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024.
We have a bold vision to go, and we do so knowing that space exploration has improved the human condition in countless ways. And it is the partnerships over the last 50 years that have ensured a steady progress in the science, technology, exploration, and discovery for the benefit of all. With America's new directive to put humans on the moon in 2024, NASA is leading the development of exploration capabilities, and we are building a coalition of nations that can help us get to the moon quickly and sustainably together.
Building on the lessons learned from the International Space Station, the key to sustainable lunar missions is establishing an orbiting lunar outpost that we call Gateway.
America will develop and launch Gateway's powered propulsion element in the near future. This outpost will be built with open standards to allow collaboration and accessibility with our international and private partners.
The first of these international partnerships is a commitment from Canada to develop advanced robotics uniquely designed for human and robotic missions.
Accelerating the timeline means a lot more focus, means a lot more dedication to the task, and we're up for it.
We are looking to our international partners to develop additional components for Gateway, to include habitation capabilities, airlock, and logistics.
Gateway is a great step towards the future of the human being. It's a great pleasure to collaborate with NASA in that endeavor.
The Gateway is not the end state. It is a piece of a greater mission that will prove how to explore other worlds. With Mars on the horizon, together we can explore more of our solar system, our galaxy, and even the entire universe, and share in the knowledge and advances that will come.
NASA is one of our major cooperation partners in space exploration.
By going together to the moon, forward to the moon, whatever the time span is, the faster the better, that's something I really like.
We welcome a growing list of partners. And through our successes, we will change our perspective on the universe for generations to come. We go together.
Space travel is hard and unforgiving.
It's always been and always will be.
It's going to be hard. There's a new chance of death. Going in a little can through deep space, it's a very harsh environment.
We think you can come back, but nothing is certain.
There are all sorts of challenges we will face on deep space missions. Communication delays, radiation protection, isolation of the crew.
So it is not surprising that some would have us stay where we are.
There's never going to be zero risk. When you're breaking the bonds of gravity, that's just part of the deal.
And it is one of the great adventures of all time.
Okay, all flight controllers, go for landing. Retro, go. Fido, go. Guide, go.
That challenge is one that we're willing to accept.
Surgeon, go.
Man in his quest for knowledge cannot be deterred.
Space is not just a destination. It changes you forever.
It'll be tough, really tough, but we have the right people for the job.
We have pressed the qualities for success into system after system.
This country of the United States was not built by those who waited and rested.
Pushed our people past every failure we can dream up.
We have never been more ready to meet the unknown.
Through Artemis, we will once again explore beyond our world.
And we will succeed.
"50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon.
We are returning to the moon.
As a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we will discover life-saving,
earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go.
We go as the Artemis generation.
We go.
Hi, I'm Chell Lindgren.
My name is Raja Chari.
Kayla Barron.
Kate Rubens.
Hi, I'm Christina Cook.
NASA astronaut Joe Acaba.
Jessica Amir.
Woody Hoberg.
Anne McClain.
Stephanie Wilson.
My name is Johnny Kim.
Nicole Mann.
Victor Glover.
Jessica Watkins.
Hi, I'm Matthew Dominic.
Jasmine Mogbelli.
Frank Rubio.
Scott Tingle.
This is what we do.
This is what we will do.
Let's go.
We go to the moon to learn how to live on other planets.
For the benefit of all.